All right. Welcome, everyone, to the Sourland Conservancy's third Talk of the Sourlands of 2025, Ghosts of the Taiga, The Secret Lives of Migratory Owls. I'm Lori Cleveland, Executive Director of the Sourland Conservancy. It's so nice to see everyone here. Thank you for coming. Thanks for braving this rainy weather. We really need the rain. Thank you to the Watershed Institute for partnering with us to present this series, opening your doors, providing snacks, tea, and coffee. Thank you. And welcoming us all to your lovely home, sharing this event with folks who are viewing online. I'd also like to thank the Sourland Conservancy staff and volunteers who work so tirelessly to plan and run our educational seminars and webinars. Please be sure to say hello to those folks on your way out. And I'd like to thank all of you for your continued support of our work. Are there any Sourland Conservancy members here tonight? Thank you so much. Members make our work possible. Together, we have planted and protected more than 60,000 trees since 2020. Now, we're losing more than 1 million, so we've got a long way to go. If you're not a member already, please consider joining us, supporting our work, and helping us spread the word. If this is your first in-person Talk of the Sourlands seminar, welcome. Here's what you can expect. I will introduce our speaker. He'll present for about an hour and then answer your questions. We'll send a follow-up email with links to books, articles, and other details that Tyler references in his talk, and also maybe some links so that you can volunteer to help the owls that Tyler's working with. There will also be a link in that email for a very short survey. Please don't skip over it, fill it out, and let us know how we're doing. We've heard from folks that they're having trouble finding us, so we really want to find out how you found your way here so that we can get more folks coming this way. We also would like to ask you again to help us spread the word through social media, word of mouth. Please help other people find their way here. We also want to hear your suggestions about how we can improve. So thanks in advance for filling that out. Now, without further ado, I'd like to introduce tonight's speaker. Tyler Christensen is an ecologist specializing in the study of and conservation of elusive wildlife. As research coordinator for the nonprofit Wild Bird Research Group, he leads research on bird migration and habitat use with a focus on owls. He's also a PhD candidate in ecology and evolution at Rutgers University, investigating how human-altered landscapes affect the spatial ecology and conservation of cryptic snakes. Thank you, Tyler. Take it away.
Thank you. Let's see, is this a microphone on its own? I'm trying to get this back. All right, how's everyone doing? Made it. Oh, thanks for the intro. Thanks for having me again. It's been a while since I've done one of these for the Sourland Conservancy. Again, my name's Tyler. I'm the research director for the Wild Bird Research Group. It's a small New Jersey-based nonprofit. We do a lot of bird-related stuff. Owls are not my day job. I mostly study snakes, like Lori mentioned. Copperheads are the focus of my PhD, which I'm wrapping up in December, God willing. Tonight, I'm going to talk to you about birds, though. So I'm sort of a bird biologist by night, and most of my focus has been on owls, and long-eared owls and saw-whet owls are two of my favorite species. We're going to talk a lot about them tonight. Starting out, yeah, this is my focal species. This is the eastern copperhead. There's me with a gravid female. My graduate research aims to understand what kinds of habitats copperheads need in the landscape, how we can provide that to them, how we can minimize human-snake conflicts. They're one of 2 venomous snake species found in New Jersey, and they're a threatened species in the state. We can talk about copperheads another time. Tonight, we're talking about owls. So again, focal species are the long-eared owl and the northern saw-whet owl. They're 2 migratory species and just the coolest birds, I think. I'm gonna do a deep dive into their ecology and their migrations and movements and what they're up to now. A little bit about Wild Bird Research Group. This is the nonprofit that I'm the research director for. So we were founded in 2011. We study a bunch of different species: songbirds, owls, raptors, hummingbirds, you name it. And we cover a lot of topics too: population dynamics and habitat selection, and mostly conservation-oriented issues. But lately, owls have been a big focus of ours. We run the Fiddler's Creek Preserve bird banding station over in Titusville, watching how the bird community changes with the reforestation that's happening at this site. We do research in the southern Appalachians along a major migratory flyway. And until recently, we ran the Nicoya Peninsula Avian Research Station, which mostly targeted winter populations of neotropical migrants, birds that breed up here in the temperate latitudes and then spend the winter in the tropics, trying to understand the threats that their populations face. But again, a major focus of ours is owls. So owls are strictly predatory. Most species are nocturnal, but not all of them. Pictures a northern saw-whet owl going after maybe a white-footed mouse or a deer mouse. And they're extremely effective predators, very good at hunting at night. And they've got a number of adaptations that facilitate this nocturnal predator lifestyle that they have. And it's also responsible for making them look as unique as they do and making owls stand out from many other birds. One of these adaptations is their hearing. So this is the face of a boreal owl. It's a close relative of the saw-whet owl. Superimposed here is a boreal owl skull. You can see it's kind of lopsided, right? It's not symmetrical. And that has to do with vertical ear asymmetry. So, most creatures that have ears, the ears are aligned, but in many owl species, particularly the strictly nocturnal ones, there's sort of a vertical offset to the positions of their ears. That helps them triangulate sound even better. So the species that have this vertical ear asymmetry are really, really good at hunting exclusively by hearing. That's probably their most important sense when it comes to hunting at night. They've done experiments where they've put barn owls, which is a species that has this vertical ear asymmetry. They've put them in planetaria and aviaries in complete darkness and saw how effective they were at catching rodents, and they're very good at it. They don't even have to see them. Their vision is also something that makes owls incredibly striking, I would say. Here's a great horned owl skull. You can see the fraction of the skull that these eyes take up is just enormous. But something that's really interesting, I think it's interesting. So owls, of course, nocturnal, but they evolved from a lineage of birds that was not nocturnal. Many nocturnal animals, including many nocturnal birds, they have a reflective layer behind the retina called the tapetum lucidum. And it reflects light back through the retina a second time. So they sort of, maybe not double, but at least enhance their light gathering abilities. Owls don't have that reflective layer because sometime in their diurnal lineage, they lost it. And so to compensate, they have these enormous eyes to let in as much light as possible. So the enormous eyes of owls is sort of a compensating strategy for that. Not all owls are nocturnal. We've got 3 diurnal species here, or at least partially diurnal in the case of this little guy. This is a pygmy owl, one of the smallest owls in North America, northern hawk owl, snowy owl. These are species that have a lot of daytime activity too. They do a lot of their hunting in broad daylight. Another feature that is not unique to owls, but it is very special, is their insulation. Owls have an incredible amount of insulation that helps keep them warm. Many owls are in cold climates. The snowy owl is demonstrating that for us here. They're also ambush predators, so they spend a lot of time sitting still, waiting for prey to come within striking distance or to move and make itself vulnerable. And so all that sitting still, if it wasn't for that insulation, they'd have a much harder time and burn a lot more energy trying to keep warm. It's also, this is a barn owl. All three of these are barn owls, fully feathered, plucked, and then just the skeleton. There's not a whole lot of owl left under all those feathers. There's so much insulation there keeping them warm. They're actually quite scrawny birds. They look really large. They've got this really bulky silhouette, but owls are quite trim and slender. Another aspect of their plumage that's just incredible is their camouflage. So we have an eastern screech owl, another New Jersey species that can be found in New Jersey. Their camouflage is just superb. They also, in addition to just the pattern that helps them blend into tree bark and other natural material, they have these ear tufts that they think that the purpose of those is to sort of help break up the outline of an owl and make it just a little bit less noticeable to a predator. And then, of course, they're extremely quiet flyers. They have a few adaptations that let them fly almost silently. So this is another northern saw-whet owl. The leading edge of their wings, the primary flight feathers, are in this close-up on the left. And so you have this comb-like structure that it's actually aerodynamically pretty inefficient, but having the leading edge of comb-like projections like this helps break up turbulence of air moving over the wing. So even though it is energetically inefficient, it renders the flight almost silent. They also have just sort of a velvety texture covering all of their flight feathers that does the same thing. It's all about suppressing turbulence and sound. So they're extremely quiet flyers for two reasons. I always thought the more obvious one was that it's so the prey can't hear them coming, right? But one that I increasingly think is more important, or at least perhaps equally important, is that they can hear the prey while they're flying. Especially because you have some species of owls, I'm thinking like short-eared owls, for example, they hunt while they're flying. They're listening underneath them, looking too, but listening. And hearing, again, is one of the most important senses that they use to hunt. They need to be able to hear their prey. And if there was a lot of turbulence and they could hear themselves flapping and gliding, they would not have as easy a time. So there's quite a few species of owls in the world, shy of 300 species, just over 250, depending on which taxonomic authority you're listening to, and then also the year, because they're making discoveries all the time, splitting, lumping, 19 of those species are found in North America. 8 of them are found in New Jersey. So we have a pretty good owl diversity here. And here's the lineup from largest to smallest, more or less. We have snowy owl, great horned owl, barred owl, barn owl, long-eared and short-eared owls, eastern screech owl, this was our lovely camouflaged buddy from a couple slides ago, and then the northern saw-whet owl on the right, our smallest. And 4 of these species are migratory and are really only found here in the winter, with a few rare exceptions. And this talk is going to focus quite a bit on these migratory species, with particular emphasis on the long-eared owl and the northern saw-whet owl. So owl migrations are not unique, the general patterns driving them anyway. They're not unique among birds, but they are a bit unusual. So many migratory birds, they have migration routes that they follow year after year. They have a breeding territory that they visit every year. They depart, they follow the same migration route year after year, potentially passing by the same landmarks, arriving at a wintering site, and they have fidelity to that site as well. So they're just making this repeat of the same migration back and forth, sometimes for their whole lives. Owls are different, owls and a few other birds. So their migrations are much more variable from year to year. they're more dependent on resources and reproduction, and we'll kind of unpack that shortly. But their migrations are a lot less predictable and consequently very interesting. So here's kind of a well-studied case. This is a snowy owl. Snowy owls, they nest up on the ground in the tundra, so they're way up in the Arctic. And one of their main food resources is various species of lemming. Lemmings are pretty famous for undergoing these really extreme population cycles where, 1 year there might be in a peak phase of this cycle where lemmings are extremely abundant, and then followed almost as quickly by a crash. The next year, lemmings might hit a low point in their cycle, and suddenly there's really none available. If you're a predator that is a specialist on a species like this, that's a pretty tough act to follow. And so when your prey cycles like this, your populations are going to cycle like this to some extent too. You can compensate a bit by moving around the landscape, trying to find places that are experiencing a peak in the prey cycle, but that's not always easy to do. And so there is an ebb and flow to the predator populations as well. So this is a snowy owl nest. Again, they nest directly on the ground. There's no trees up in the tundra, hardly any woody vegetation, so they make do. They nest right on the ground in a little scrape. They may lay 4, 5, 6 eggs, sometimes even more. And in an average year, and the typical thing, the female will incubate the eggs exclusively. The male will go out and hunt and bring her food. Once the eggs hatch and there's little owlets there, she'll continue to sit there, brooding them, keeping them warm. The male continues to bring food. Once they're a couple weeks old and they have their first set of downy insulation and they're a bit larger and more independent, she'll join the male, and then they're both gathering food. And that's sort of true of all owls. They kind of have this pattern. Female incubates, broods the young. The male's the one doing most of the feeding for the first 2/3 of the nesting cycle. This is what a nest might look like in sort of a typical or perhaps a low lemming year. There may not be enough food to go around for all these babies. They have a staggered cycle where I think we're going to save questions till the end because there's going to be a microphone going around for the folks that are on Zoom. Yeah. Normally I like to make this a conversation, have questions throughout, but not tonight. So in a typical year or even a low year, the oldest chicks, oh yeah, I remember what I was saying. So most owls, most raptors, in fact, they'll lay eggs, once every couple of days until they have a full clutch. Most birds, like songbirds, they'll lay a full clutch, or chickens, they'll lay a full clutch and then start incubating so that there's synchrony. They all start developing at the same time and they all hatch at the same time. So all the chicks are the same age. Raptors don't do that. They start incubating right away with the first egg so that that one will hatch first, then the next one a couple days later, and so on until the last egg hatches. So you have quite a bit of difference in age and vigor and strength in the owlets in a nest. That might be adaptive because when there's not a lot of food to go around, it's the youngest eggs, the youngest chicks that usually don't survive. They'll be bullied and outcompeted by the older ones. So in a low year, it's very possible that not all of these young will survive. And that's just the reality of being a predator trying to follow a really dynamic food resource. But in a peak year for lemmings, the situation's very different. So this is a snowy owl nest in a peak lemming year. So this is a volcano of dead lemmings that the male, pretty much exclusively the male, has brought to feed the female. And they don't seem to have an off switch, They're really enthusiastic about bringing food to the females. There's pretty much no way that they're going to eat all these, but suffice it to say that all of these young will probably survive. They'll be healthy, they'll be fat. And so in a good year, good lemming year, the population of snowy owls may suddenly double or triple. All of these young owls enter the population. If a peak is happening, that's all well and good, but as winter approaches and the population of predators has tripled, they quickly deplete the available food. Those are the years that they have to leave the tundra and many owls have to migrate to find enough food to survive the winter. And so does anybody, who are the birders among us here? Nice, good, representing. And do you remember the 2015 to 2016 eruption of snowy owls? It was quite a historic one, and this probably followed on the heels of an epic breeding season where maybe there were multiple regions where the lemming populations were in synchrony and all at peaks in their cycles. Snowy owls just had a banner reproduction year, ran out of food, and then they turned up all over the East Coast. So these are eBird sightings of snowy owls in the winter of 2015 to 2016. They were turning up all over the place, just these pieces of the tundra that get sent down because they ran out of food. So this is true, even though the snowy owls are a really relatively well-studied example. This is true of all of the owl species that specialize heavily on one or two species of prey. And so for snowy owls, that may be the lemming species. For long-eared and short-eared owls, that may be meadow and redback voles. For northern saw-whet owls and boreal owls, that may be these two Paramiscus mice, the white-footed mouse and deer mouse. But they're following these, what they have in common is they're following these rodents that have pretty extreme population cycles. And so their populations cycle in tandem and their movements vary in tandem. So the northern saw-whet owl, again, this is going to be a major focus because we do a lot of work with this species. This is the smallest owl in eastern North America. About 90 grams is the average weight. For reference, that's about the weight of a deck of playing cards or a stick of butter. Almost exclusively, they're eating mice and at more northern latitudes, redback voles. Rarely they breed in New Jersey. It does happen. It's unusual. For the most part, they're breeding to our north. But many of the ones that migrate through here eventually come, late November. They'll stick around and spend the winter here. So they are a winter resident. You can see northern saw-whet owls during the winter with difficulty. They're very good at hiding. Snowy owls, I'm sorry, saw-whet owls kind of made the news a couple of years back with Rockefeller the owl, which, who heard about this one? Yeah, it's a pretty famous saw-whet owl. It might be the most famous saw-whet owl that there's ever been. So yeah, for those of you who don't know, which at least in the room isn't many, yeah, they were bringing the big Norway spruce down from upstate New York to put at the Rockefeller Center tree, and they wrapped up the tree, shipped it down, and when they unwrapped it, there had been a roosting, probably sleeping saw-whet owl in the tree. I don't know how or why it stayed during that disturbance, but it did. The owl was okay. It went to a rehabber, they evaluated it, took it back up to upstate New York and released it, but not before it got internet famous. That's right. So they're cavity nesters. They don't make their own cavities. They adopt cavities of other bird species, mostly woodpeckers. Sometimes they'll use other forms of natural cavity, like just a rotted limb, a natural hole in a tree. But for the most part, they're co-opting existing cavities that are made by woodpeckers. And analogous to the snowy owl nest when it was surrounded by dead lemmings, this is what a saw-whet owl cavity looks like in a really good mouse year. And so this is a female. She's either on eggs or on young. This isn't my photo, so I'm not sure. But the male has brought her this beautiful platter of dead mice. Yum. And after this, her babies are probably all going to survive. She might even be able to fit in 2 broods in a single season. So for some fraction of nests, especially when there's a lot of food around, the female will actually leave the male to sort of finish rearing the babies, and she'll go off and join another male and have another nest all in the same season. So again, you get this situation where there's just explosive reproduction, lots of young owls are entering the population, and you wind up with these big migrations. So for snowy owls and short-eared and long-eared owls and all the owls that follow this pattern, these are called eruptive migrations. For saw-whet owls, that means, okay, so the purple here is the typical breeding range and year-round range. In a typical migration, that's this darker blue color. They'll travel south from these, from this breeding range and maybe make it a bit past the mid-Atlantic. But in an eruption year, that's this light blue, you'll wind up with much larger migrations, and a much larger fraction of the population is migrating. There's just many more birds on the move. And so how do we know all this about owls? Well, a lot of what we know comes from bird banding, from owl banding in particular. And this is one of the research projects that we're involved with. We catch and band saw-whet owls during their annual migrations. We do that here at the watershed, and we do it with the Mercer County Park Commission over at the Hunt House, both sites in Pennington. And bird banding involves fitting the birds with an aluminum leg band with a unique number. All these bands are distributed by the U.S. Geological Survey's bird banding lab. They're the ones that issue permits for this, and they also manage the database, the data repository. So anybody banding birds in North America, including in Canada, gets their bands from the bird banding lab and reports their data to the bird banding lab. That way, we can find out very easily when and where a bird was banded if we recapture it or recover that band. And in that way, we can sort of piece together from these recapture events, we can piece together the life histories of these birds. Now, despite the simplicity of bird banding as a method, it's still one of the more cost-effective ways of studying migration, especially of a tiny bird like a saw-whet owl. Again, deck of playing cards. GPS technology and MODIS and VHF telemetry of other kinds. It's really great, and it is rapidly improving, but there's still some pretty severe body size constraints that dictate which species you can apply these technologies to. And believe it or not, when you have a nocturnal owl that doesn't spend any time in the sun, a lot of the GPS transmitter options are ruled out because you can't put a solar panel on it, it can't recharge, you're relying on whatever battery you can put on board. And so, that's not a very long-lived transmitter. I do have some updates about that because, like I said, technology is rapidly improving, and I'll update you on that later. But for the most part, bird banding remains one of the more effective ways of studying bird migration, especially with these smaller species. So what can we learn in general from banding birds? Well, I can tell you these are out of order. Let me just bring them all up. We can learn a lot about their population dynamics, causes and patterns of these eruptive migrations, especially if we can link them to environmental variables that sort of underlie them. Migration connectivity, where are these populations coming from? Where are they going? For example, here in New Jersey, where are our saw-whet or long-eared owls coming from? What part of the continent is supporting the populations that come here to New Jersey? And a lot of this has been revealed through bird banding. So when we catch owls, we're using mist nets. You can't even really see it in this picture, but it's suspended between these two aluminum poles. It's a 40-foot long net that's about 8 or 9 feet tall that we erect at sunset. We keep them up for 5 hours. We check them every 45 minutes when they're open, and then we take them down again. And we do this during the saw-whet owl migration, which is at our latitude, early October to early December, approximately, those 2 months. We attract owls to these nets using audio lures. By the way, how many of you have come to an owl banding program here at the watershed? Nice, welcome back. We use these audio lures to attract them to the nets. These are all homemade things. You can kind of tell by the state that they're in and just how they look. But yeah, these blast saw-whet owl vocalizations. And for whatever reason, even though they're not territorial at this time, they're not breeding at this time, their curiosity is piqued enough to pause their migration, come down, investigate the source of this sound, and they'll get caught. We band them, process them, take the measurements we have to, and then send them on their way. So this is one of our volunteers, Jack Hagan, extracting a saw-whet owl from the net, which gives you a sense of scale too. I think this is the first picture where a bird and a person have been pictured together. That's a full-grown saw-whet owl. And like I said, we check these nets frequently because, these birds have to take time out of their busy schedules. We don't want them to waste too much time with us. And so in a pretty good year, like an eruption year of saw-whet owls, we'll have nights like this where we run out of bags and there's more than enough owls to go around. So these are all northern saw-whet owls that we caught on a single net check. This is over at the Hunt House in Pennington. We've had just as busy nights here too, so happens both places. And so for us, these eruption years look like these amazing peaks like this 2018 with 329 owls in one season. That was sort of a historic season for us since we started in 2014. That was our biggest year. 2024 wasn't bad either. We caught nearly 200. And the migrations throughout the season, they're not uniform. There are nights where it's much better, clear nights, cold nights with gentle north winds, dark moon. These are things that seem to motivate owls to migrate. And on really good nights in peak migration, which is usually, around Halloween, around now, in a good year, the most we've ever caught in one night is 65 owls. Many nights we catch 0, so it's so variable that we never know what we're going to get. We can make some pretty good guesses. We've learned quite a bit over the last 12 years, but it's still surprising. We never know exactly what's going to happen. So we're not the only ones doing this either. The reason that we can learn so much from bird banding is through recaptures at other banding stations. And so birds that we band being recaptured elsewhere, birds that have been banded elsewhere that we recapture here. And this may happen, 1, 2, 3 dozen times a season for us that we're recapturing somebody else's bird and vice versa, our birds being captured elsewhere. And through these connections, you can piece together quite a bit about their migrations. And something we're working on now is using the National Banding Database to see how these eruptions change over time, but also in space. And so these dots represent individual banding stations, and the size and color of the dot represents sort of a standardized metric for how many owls were caught at that station in a given year. And so the larger and lighter blue points are like a lot more owls than that particular station catches on average. And so as we go through this cycle, you can see which years the eruptions were. There was one big eruption in 2012, so that's coming up. Watch the sudden blossoming of all these light blue points. 11 and 12, big year. 2018 was another big year, but only in our region. Ready? Bam, right there. So it's really variable where these eruptions occur, not just when they occur. So that's probably connected to what parts of their breeding range are experiencing these peaks in the rodent populations, or maybe other favorable conditions that drive where these eruptions are happening. Could also be related to wind conditions during migration. They may just follow favorable winds. We really don't know. So despite all that we do know, there's still a lot of mysteries about saw-whet owl migration and migrations of owls in general. Saw-whet owls are one of the better studied species because of how many people have saw-whet owl banding stations and are targeting this species. A lot of what we know about other species, or at least a lot of what we think we know, has been inferred from details about migrations of species like saw-whets or snowy owls, which are better studied. Another piece of evidence that lends itself to explaining these eruptions is we can actually see the demographics of the population change in years that we catch a lot of owls. So capture rate is on this horizontal axis here. In those years, there's a higher ratio of young birds, implying that it was a really good reproduction year. The makeup of the population has actually shifted toward more young birds. The population is actually comprised of more young individuals. And so we get this certainly not perfect and definitely messy, but still positive relationship. And other stations can see this as well. So we get to see the evidence of their breeding even at this latitude where breeding does not really happen very often. So this is a video I'm going to show you. The way that we can determine the age of these birds, you can see a couple of you already know what's coming, right? The way we can determine the ages of these birds is really interesting, I think. So all birds have to replace their feathers every year. The feathers wear out, they're remarkable structures, but they don't have the best longevity because of how lightweight they are. And so they have to replace their feathers, but they don't replace all their feathers every year, at least not all species do. Saw-whet owls just replace most of their feathers each year. It may take a few years before they completely replace their feather coat. And so the patterns by which they replace their feathers change as the birds get older. So if you can recognize which feathers have molted and which have been retained, if you can recognize that pattern, you can assign an age confidently to the birds. It's not perfect. We can't say this bird's 8 years old, but we can say this is a hatch year, this one's a second year. Sometimes we can even say this is a third year. After that, we just know that it's older than that. Now, for most birds, we're really scrutinizing to look for differences in feather wear and color, trying to discern the newer and younger generations of feathers. In owls, they've kind of given us an easy way out because when they molt their feathers, they deposit a porphyrin pigment that fluoresces under ultraviolet light. That fluorescence fades as the feathers get older and exposed to sunlight, and so the older feathers fluoresce less and the newer feathers fluoresce more. So it makes recognizing those age-specific patterns really easy. So this, if I recall, this was a hatch year owl, and this is just demonstrating the fluorescence itself. You won't see much of a pattern except just uniform fluorescence under the wing of this owl. Let's see if this works. All right, so I spread the wing, I have someone shines a UV light, and boom, bright pink fluorescence. Uniform fluorescence across the wing tells us all those feathers are the same age. They grew at the same time. The only time in that owl's life that will happen is when those feathers are growing when it's in the nest. They grow all at the same time. After that, they replace them more erratically, and we can recognize the patterns. And so here's a hatch year pattern, which we just saw. Ignore the years on the bottom. This was pulled from an old slideshow. This is a second year pattern. It's much easier to see in person, but you can see more fluorescence on the outermost and innermost feathers, and these feathers in the middle are 1 year old. So that's how much the fluorescence fades after a year. And sometimes you can recognize a third year pattern, but very often we just have to assign an after second year category to owls that are any older than second year. So we know it's at least 3, but we can't say specifically how old. Now, thankfully for our data quality, but unfortunately for the owls, the vast majority of birds that we catch are hatch years. We catch a few second years. After second years are very unusual, and that partly has to do with the composition of the population, just because of how many young owls are added to the population each year. But it's also because they have really significant mortality in their first year of life. And so the vast majority of owls we catch are young. Something like 80% of first-year owls don't survive that first winter. So they have very high mortality. And so I mentioned the fluorescence breaks down with exposure to sunlight, right? So if you shine the light on the owl's body, which is exposed to sunlight all the time, there's really no fluorescence. But if you look at the legs, they fluoresce bright pink. Ooh, had to sneeze. They fluoresce bright pink because they never see the sunshine. So we do, after migration, we had other questions about saw-whet owl biology and ecology. So we've extended this research into some winter habitat and winter ecology research. One of the questions we had is what habitats they're choosing to roost in. Information on saw-whet owl roosts mostly comes from birders, from people who went out looking for saw-whet owls, found roosts and documented them in some way. Many even more formal studies were based on that kind of survey effort. But time and time again, it's shown, especially with cryptic and hard to find species, that those types of survey data are very biased. They're biased toward the places that people are looking for them. Maybe they're looking for them there because they're unusually easy to see in those habitats. Maybe they're looking for them there because of past knowledge of, that they've been seen there before. And so we wanted to see the extent to which that was the case for saw-whet owls here in New Jersey. So we put radio transmitters. This thing on the left is a radio transmitter customized with a little leg loop harness that fits on them like a climbing harness. So it fits around their waist. The transmitter sits on their back. This emits a VHF signal, a radio signal that we can receive using an antenna like the one that this person's holding here, and a handheld receiver. And so that lets us play Marco Polo with the owl until we find it. And so here's an owl in a sort of conventional roost, I'll say, in a conifer. This is in an eastern red cedar. They seem to like cedars because they have dense foliage year round. They don't lose their foliage in the winter, and so they stay pretty sheltered from the elements and from predators. And this is the kind of place that we were expecting to see saw-whet owls, especially between, I'd say, 6 and 15 feet in height, because that's where most reports are from. That's where most published literature suggests that they'll be. And we did find them in those places. However, we also found them in a lot of deciduous roosts, especially early in the season, like November, December, when a lot of deciduous trees were still retaining some of their leaves. And we also weren't finding them close to the ground. Very often they were way up in the canopy. There's a saw-whet owl up there. We first found it thanks to the signal and then spotted it using a spotting scope. So very frequently they were using places that they hadn't been documented in before. And we also got to see this nice clean transition between more deciduous roost to more coniferous roost as the season progressed. So as we get later and later into the winter, the ratio of deciduous to evergreen roosts goes down, and the frequency of evergreen roosts goes up. As the deciduous trees lose their leaves, they start using the conifers. The other species we've been focusing a lot on is long-eared owls. And I have a bias. It's my favorite species. I think they're really fascinating. They're much sought after by birders. They're quite rare. They're a threatened species in New Jersey. And it's very difficult to get a glimpse of them. They also appear to have eruptive migrations, although they're much, much less studied than some of the other species we've talked about tonight. I'm guessing you can tell about when this photo was taken. Yeah. So they're bigger than a saw-whet, a medium-sized owl, about 300 grams. And not only are they one of the less studied owls in New Jersey, that's true of North America. And some sources even say it's the least studied owl in the Northern Hemisphere. And so there's not a whole lot of research into their migrations, their habitats, or more concerningly about their population trends. So I mentioned they're state threatened. That is true of both their breeding and non-breeding populations. Breeding in New Jersey has become increasingly rare. It used to be a bit more common, but it could be that the declines are due to them sort of receding or retreating northward, or just habitat loss. We're really not sure. Mostly they are a non-breeding resident that's here for the winter. And so long-eared owls are arriving around now. They'll stay for the winter, and then they depart in the spring. And one of the coolest things that they do, at least here in the winter, is they roost together. They'll form diurnal roosts of many individuals. Sometimes like two to 5 is pretty typical, but 10 or more is not unusual. So catching long-eared owls is a little bit different than catching saw-whets. Essentially the same, but often we're doing this in the middle of winter, so a bit different. Here's a couple of long-eared owls together. They're just so charismatic, really fascinating. A lot of people are surprised at how small they are in the hand. They look much bigger in the field, and just photos of them look bigger, but they're quite small and lightweight. Not so much as a saw-whet, but they're only a bit bigger than a screech owl. So they also fluoresce under UV light. The patterns are a bit different, though. So here's a young owl on the left and an adult owl on the right. And here's what the fluorescence looks like in long-eared owls. So the hatch ears on the left fluoresce a lot less brilliantly than the adults, and a few other subtle differences, but that's the important one. So winter plays a really important role in their, habitat plays an important role in their survival during the winter. So winter is associated with the highest mortality in this species, and indeed most raptor species. They have less prey. They're less concealed from predators because the foliage on the trees is gone. And because it's cold, they have a lot higher energetic demands required to keep warm. They're burning a lot more energy. And so they can help their winter survival by choosing their habitats wisely. They can choose habitats that have greater prey availability, choose habitats where they have an easier time avoiding predators and hiding from predators, and habitats where they can take refuge from the cold winter weather. So what is known about long-eared owl winter habitat? They're more nocturnal than their close relative, the short-eared owl. They're in the same genus. And a lot of what is thought and believed about long-eared owls is just inferred from their close relatives that are a bit easier to study because they're crepuscular or even diurnal. Direct observation of long-eared owls using habitat and selecting habitat is really tough because they're scarce, they're secretive, and they're nocturnal. And many nocturnal creatures are much more poorly studied than diurnal counterparts. Information about their nocturnal foraging habitat is mostly based on analysis of their diet, which is relatively easy to study, and information about roosts, for the same reason as saw-whet owls, is subject to bias, and there really haven't been any systematic studies of roost site selection in long-eared owls prior to us getting at it. So the reason diet's easy to study is because these communal roosts, when they get together, they're eating their rodents, they're regurgitating the undigestible parts, which includes the bones. There's just piles and piles of pellets. So here's, on the left, we used to collect pellets from long-eared owl roosts. I have garbage bags full of long-eared owl pellets. A particular roost will eat thousands of voles in a season. It's really amazing what they can do to a vole population. And here's the composition that we've seen so far in the dissections we've done. More than 90% of what they're eating are meadow voles. In seasons when meadow voles are less available, maybe because of snow cover, maybe because of population dips in meadow voles, they'll transition to other prey, but meadow voles is the main part of their diet. Now, one of the original inferences that used diet to infer habitat selection was this one from 1961, which has since been studied many dozens of times. So Lowell Getz says, several studies have been made of the feeding habits of the long-eared owl and have shown the species to feed primarily upon small mammals, particularly the meadow vole, Microtus pennsylvanicus. This would indicate that the long-eared owl utilizes open, grassy habitats as hunting areas. And so since then, many studies have repeated this same thing, citing Getz and also citing the fact that short-eared owls, which have similar diet, do this, but at dawn and dusk. But surprising to us, at least, was that no direct observation studies of foraging had been done in North America, and only one or two have been done in Europe, because there's a European subspecies as well. And so surprisingly little is known about what they actually get up to at night, what habitats they're hunting in, and how they hunt them. And so sort of the model, if you want to draw a map of how long-eared owls are using habitat, they would align with short-eared owls and northern harriers, which are two grassland species that forage in open habitats in meadows and grasslands. They hunt on the wing, they listen for voles or look for voles beneath them, and that's their primary habitat and their primary mode of foraging. And as you transition from grassland to young forest, you would expect less use by all these species, which has obvious management implications because we're talking about 3 different species of threatened grassland raptors. Special concern in the case of the harrier. So we wanted to put that to the test. We caught a bunch of long-eared owls. We put radio transmitters on them. We tracked them at night, and then this was difficult, but we watched them using thermal cameras. Hours and hours of monitoring, just seeing what they were doing and in what kinds of habitats. And we were able to follow them throughout the night, using the thermal cameras and radio telemetry. And so I'll show you a quick video of what it looked like behind the thermal camera because it was pretty cool. This was pitch black, but you can see the owl perched in a tree here. It's pretty dark, which indicates a cold surface, but when it looks at the thermal camera, you can see its face is just bright white heat, white hot, because those are the eyes and the facial disc glowing. And so this was pretty typical. We would see them perch hunting. We would watch them attacking voles from perches, not from open grasslands, but from edges and perches. And so that study's not been published, but the takeaway here is that most of the hunting was in, so these are the major habitat categories. None of these are mutually exclusive, but the important habitat categories were shrubland, woodland, and edge made up a lot of their foraging time. A tiny minority of their foraging time was spent in meadows, which runs counter to what's currently understood and widely published about them, which again is a problem for management if you're trying to create or maintain habitat for long-eared owls. So these are the kinds of places we would frequently track long-eared owls to, just dense shrubland and small clearings and edge habitats like this, where they would hunt from perches. These habitats still have meadow voles, but I feel like the quintessential meadow vole habitat is out there in the middle of the grassland, which has misled people for decades. And so here's what we think now about how these species stack up. You have long-eared owls using young forests and less so using grassland. All right. Roost site selection, I see I'm running out of time and I've got more stuff I wanted to share with you, so I'm going to skip over some of this a bit. Very quickly, I will say roost site selection was somewhat similar. We still found them using conifers. Here's a communal roost. How many owls do you see? It actually took me a while to find them all. Okay, it's not the most fair picture either, but there's, I think, what is this? 3, 4, 5, 6, is that 7? Yeah, you can't really see the one in the upper left very well, so if you didn't see that one, I'll forgive you. Yeah, pretty cool. But basically what we found was that they were choosing home ranges with young forest, coniferous forest, and they were choosing the densest patches to roost in. They were not selecting home ranges with disproportionately more edge or agriculture, which would be expected if they were sort of, more open country species. That could also be a product that we did this only in the northern Piedmont, which is very fragmented, so edges were not in short supply, which would, just the way that these models are formulated, would weaken selection, for those habitats. Anyway, yeah, so very tied to early successional habitats was basically the conclusion, both for roosting and for foraging. Now, their migration, that's the last topic I wanted to cover with you, but there's a bit of material there. And in my opinion, the most exciting stuff that we've done with long-eared owls over the last 6 or so years that we've started working with them. So migration is also pretty poorly studied, depending on how you look at it. So this was a summary of banding records between 1925 and 1999. This was published in 2005, so it's quite an old study, but this was the last study on long-eared owl migration. So each of these points was an origin where birds were banded, and each of the stars is where the band was recovered. And if memory serves, there have been thousands. I think it was around 1,100 banded long-eared owls in North America up to that time. No, I got that wrong. Order of magnitude wrong. It was 11,000, and only 115 or so had been recovered. Most of those had been recovered within the same study site, so the birds didn't even leave. Maybe a nestling that didn't go anywhere. But some of these recaptures and recoveries, these were all dead birds down in Mexico, but they show the capacity for long-distance migration. But banding is really all that anybody's done. And kind of take note of where the northernmost recovery points and banding stations are. Southern Canada, southern Quebec, southern Ontario, just north of the border. So GPS, we talked about it earlier, it has revolutionized the study of bird migration. We've been able to look at, with such fine detail, we can track migrations of many species of birds. But there are limitations. Beautiful snowy owl migrations, large bird that roosts in the sunshine, so you can use a solar-powered transmitter. Short-eared owls, this was a relatively recent study. We actually took a lot of advice from one of the authors, Travis Booms, about how to attach transmitters to short-eared owls, because long-eared owls are so similar structurally. So nobody had tracked long-eared owl migration with GPS before. They roost in the shade, they're nocturnal, no opportunities for solar rechargeability. That's a problem, but we figured that programming the transmitters on really energetically conservative fixed schedules, where we won't get a point every hour, we may get 1 point every 2 days during migration. We figured that was good enough to just address the question of where they're going and how they're getting there. We didn't need a point every hour to answer that question. And so these transmitters, they weigh less than a AA battery. They have a battery on board. There's no hope to recharge them once they're deployed, but they last, under that conservative fixed schedule that we programmed, they'll last several years, which is about as good as a solar-powered transmitter. We just get less quantity of data from them. But it was a trade-off that we were willing to accept, especially for a pilot study. And the owls did not disappoint. So here's one wearing one. This is what the backpack looks like. It's sort of an X configuration that crosses in front of the keel, right? So this was the first owl that we released. We released 2 within a week with the first GPS transmitters, and they did some pretty incredible things. I'm going to have to skip this, unfortunately. So the first 2 owls, this is the previously published range limit for long-eared owls in eastern North America, and this is where the 2 GPS tagged owls went. This one went hundreds of miles beyond that range limit and spent the summer up in northern Quebec, a really remote part of northern Quebec. This owl traveled quite a bit beyond the range limit, but then did like a retrograde migration and was just, I think it was about 50 miles from the, that range. And that's a soft range limit. It's not like the birds read the books. You expect to see some variability there, but not this level of variability. The owl whose points and lines are in black was stationary for quite a long period, indicating that it probably successfully nested up at those latitudes. This owl likely did not. It was too short. It probably attempted to nest but failed for whatever reason. We did note that it didn't arrive on its breeding grounds until much later than we would have expected. And so we continued tracking long-eared owls, and they continued doing this. We had wondered, was this a fluke, or is this something that's happening consistently? It's consistent. So here's that range limit again, and here's every long-eared owl we've tracked since. Almost all of them are actually going hundreds of miles north. Okay, not all hundreds, but many of them are traveling quite far north of that range limit and nesting in this part of Quebec. Completely undocumented. Nobody has seen them up there. I think there's like one eBird report from up there that was written off as a vagrant. It's pretty incredible stuff. And all of these birds are being banded and tagged here in Pennington, and a couple from 6 Mile Run up in Franklin Township. And so here's kind of a close-up and also showing level 1 ecoregions. There's that range limit again. Here's just the summer locations of our GPS tagged owls. And you can see that by surpassing that range limit and then some, many of these owls are entering the taiga. They're entering spruce lichen woodland, which is a biome that has not been associated with the species, at least for nesting here in eastern North America, which to us seems significant. This is the region of Quebec that's experiencing these intensifying wildfires, like all the smoke that we had a couple of years ago. That's this region of Quebec. And so, our wintering population of state-threatened long-eared owls is relying on this region that we didn't even know about, likely facing threats during their annual cycles that we weren't aware of. Again, to us, that seems pretty significant. Not all of them are going that far north, but most of them are doing some pretty unexpected things, and we love to see it. So this is what the landscape looks like up there. This was taken from part of that owl's summer range. Really bizarre, textured landscape. We were so intrigued by this, not just the discovery about how far they were going, but also just the appearance of the landscape up there. Really incredible. And yeah, so here's a little snippet of one of those owls' home ranges. You can see many of its points. Just zooming in on some of those, you can see what, some of these habitats might be like. You've got these denser canopied forested areas, these relatively open areas with whatever that white stuff on the ground is, and then these open, what we figured were bogs, and we wound up being right. We were so intrigued by all this and just by the discovery, we actually went up there and to try to photograph representative habitats of the kinds that were found within the home ranges of these owls that were breeding up there. Yeah, and we took a drone up with us too to photograph these habitats. There's a couple of roads that go up in that region. One of them just so happens, I'm going to back up a little bit. One of the roads just so happens, the James Bay Highway goes up here, ends about here, but then there's a road that goes east from about here, east to right there. And so we were photographing habitats relatively close to where that green point was. That road was built to access a couple of hydroelectric dams that were built by Hydro-Quebec, back in the 70s, if I recall. Anyway, so that's the one road in the region, and it just so happened to end pretty much right at a long-eared owl. All right, fast forward. Beautiful landscape, open bogs, closed canopy conifer forests, a bog, this is called a flark string bog, new term for the night, and spruce lichen woodland. And these habitats, many of them anyway, just seem perfect for long-eared owls. Really wonderful landscape, and so just vast remote landscape. Very, very low human population up there. It's mostly First Nation Cree people who live up there, and mostly still live off the land, hunting camps and fur trapping and stuff at a very low population density. Here's one of these bogs, just incredible. Here's what one of those bogs looks like on the ground. And each of these bridges is just sphagnum peat moss. They're very soft, squishy. This is all, it's all reindeer lichen. That's what all that white color on the ground is. So this is the spruce lichen woodland, and it's characterized by large spaces in between the trees where the ground cover is pretty much entirely reindeer lichen. Here's what that looks like a little closer. And so this is where our long-eared owls are going. It's just one of the most magical things. You see a long-eared owl here in New Jersey, this is what I want you to think of now. This is where they're coming from. This is probably where they were hatched, They also have access to these older bogs. Fabulous perch hunting, you can imagine, if that's what they're doing up there. Also, other lovely birds up there. This is a spruce grouse, a male spruce grouse. And then this was a life-changing experience, a northern hawk owl. Really loved that. And then just our last night there, after we photographed all these habitats, I happened to have to go to the bathroom at like 2 in the morning, and I looked up and this was happening. I had no idea that, that was going to happen. This was in August too, and it was an unusually bright aurora. Just lucked out. And so just a quick update on this. We only have one long-eared owl currently GPS tagged that's still active and alive. And that owl has just recently initiated its southbound migration. I don't have the range limit on this map, but it's approximately here. Range limit, I know, it means nothing now. But, so this was one of our most northerly migrating owls in the study to date. You can see we have a couple of points, these pink dots to the north of that. But this owl has now initiated its southbound migration. I downloaded the last fix on the 15th, so not too long ago. It has probably gone a bit further than that now. They have really slow meandering migration southward, which is kind of consistent with the idea that they're only going as far as they need to, as far as the resources and competition dictate. It might take this bird another month or 2 before it gets back to our latitude, if it even does. So far, these owls have had no site fidelity. They're not coming back to the same wintering site year after year. And so birders, including myself, who thought that when we were seeing long-eared owls in the same habitats year after year, those are just different owls that are following the same sort of internal rules governing what they consider high-quality roost habitat. This has been backed up by people banding them too, where they'll catch an entire roost of owls, band the birds, release them, that roost will be back the following year, not a single banded bird. They're all new. So they have no site fidelity, which is I shouldn't say none, but because we don't know that for sure, but very low site fidelity. So other news, let's see, we're in our 12th year of saw-whet owl banding. You can sign up for public programs. We do demonstrations where, if we're lucky and we catch owls, you can see the banding process, you can see the owls in person, you can see the UV aging process. It's fun stuff. So registration for those programs is handled by our partners here at the Watershed Institute and at the Mercer County Park Commission. And so if you prefer Fridays, this would be the location. If you prefer Wednesdays, the Hunt House with the Mercer County Park Commission would be the location. If I was more prepared, I'd put QR codes or something, but if oh, that's a great idea. Yeah, thank you. Very good. Now, the other cool news I wanted to share, I alluded to this earlier. The company Lowtech, very unfortunate name, it's a Polish company. They just recently came out with a transmitter, the lightest of its kind, that is just light enough to be deployed on saw-whet owls. And so we have a couple of these transmitters in hand now. We're ordering more. We're planning on deploying some of these this winter here in New Jersey and also with some collaborators in North Carolina to try to, because they're a threatened species in North Carolina, and to try to track their migrations in exactly the same way that we did with long-eared owls. It could be, as was the case with long-eared owls, that the distribution of banding stations was just not aligned with the distribution of long-eared owls. And so they were able to do things outside of the range of these banding stations that no one was seeing. It could be that saw-whet owls are doing the same thing. We just don't know. So hopefully we'll have some answers. But again, it's not my day job. We're run by volunteers, and so progress is slow. We all have full-time jobs and other lives outside of owls, unfortunately. And that's all I've got for you. Thank you. Yeah, be happy to answer questions. So you're going to be caddying the mic. Yep, great.
Thanks, Tyler, for a great presentation. That was a good show.
Very welcome.
You mentioned several times that these owls that you're talking about have predators. What are those predators?
Great question. So northern saw-whet owls, they're extremely vulnerable to predation, mostly by other owls. And just about every species of owl larger than them is a potential predator. So, eastern screech owls, long-eared owls, great horned owls, they'll all go after a saw-whet owl. Just an example, and actually this is predation on a screech owl, but one of our longtime volunteers and now one of our board members, actually our board president, the reason they got in touch with us initially was because they found an owl pellet in their yard. It was a great horned owl pellet, which they knew because they had like a resident nesting great horned owl. They dissected the pellet with their daughter because that's a fun thing to do, and there was a band in it. They reported the band. They were put in touch with us. They contacted us, and it was like, yeah, that was a screech owl that we banded here at the Watershed back in 2018 or so. Yeah. So yeah, larger owls especially. They do a pretty good job hiding during the day, and so diurnal raptors like Cooper's hawks or something, red-tailed hawks, they hide pretty well from those. It's when they're active at night that they're most vulnerable. Yeah. So Lori's going to bring the microphone around so that the people on Zoom can hear.
Hello. Is there any way to attract them to a neighborhood type of environment where they would live?
That's a great question. For saw-whet owls, it's tough. I think the best thing you can provide for them is roost habitat in the form of conifers and evergreens. For something like a screech owl, though, which is another cavity nesting and cavity roosting owl, they make owl boxes, or you can get owl box designs and make your own. sometimes if you go that route, don't be discouraged if you don't get one in your first year or two, because they're pretty long-lived, and once they do adopt a box, they'll use it for years, but it may take them a few years before they do.
So owls have big eyes and big pupils. A camera setting with a large open iris, you have a very narrow depth of field. Is there a penalty for having a big eye and a big pupil?
That's a really good question. I don't know. Yeah, I've never considered that, and I haven't read anything about it either. But you can believe I'm going to look that up when I get home.
Okay, thank you.
Stumped him.
There's a question online. So Anita wants to know, do owls come back to the same spot to roost during migration?
Another really good question. So our knowledge is limited. I can speak to long-eared owls and what they do. I'm not sure about saw-whet owls. For the long-eared owls, it really seems like not only are they not faithful to wintering sites, they have no fidelity to their migration route either. They go different direction each fall. And so I have to assume that they're, okay, actually, there is a study that's going on that we're doing right now with all of our migration data where we're trying to figure out where they're choosing to stop over. We haven't seen any fidelity to those stopover sites. It seems like they're just, choosing whatever sort of fits their model of good habitat. For them, it seems like places that at small scales, really dense forest, which makes sense because they're roosting in, protected places. And then at larger scales, they want habitat that's incorporating at least some open and edgy habitat so that they can hunt in. So kind of a multi-scale selection thing. So we understand why they're choosing their stopover sites a little bit, but it seems like they'll choose them anywhere, not the same ones year after year.
What's the life expectancy of these owls?
Oh yeah, so both species we study, and I think eruptive owls in general, they're surprisingly short-lived. They can get relatively old. The oldest wild saw-whet from banding data is something like 9 years old, maybe 10 years old. But typically, again, most of them don't survive their first year. Ones that do survive their first year, they have a slightly better chance because they're more experienced now. 3 to 5 years is pretty normal. But seeing a 8 or 9 year old owl is very unusual.
I was curious about the food in the northern parts in Quebec and Canada.
Mhm.
Do you have, I know you get from pellets down here, but do you have a sense of what they may be eating there that's, what that environment provides?
Yeah, I've put some thought into that. We didn't find any pellets up there to collect or dissect. We didn't do any small mammal, anything, surveying, monitoring of any kind. But based on what I've read, it seems like redback voles are probably the most abundant prey for them up there, and probably the most appropriate for them too, size-wise. They all sort of have their size window that's ideal for them. I bet it's redback voles, but we still have to dig into that before I can say confidently. Yeah.
Do you think that more northerly travel is due to the habitat that maybe we didn't know about, or that it's warming because of climate change?
That is a $1 million question. My feeling is that they've probably been doing this and we just didn't know about it. It's hard to say for sure. I actually just last week, we finally got in touch with some wildlife biologists who work for the Grand Council of the Cree up there, because a lot of these owls are going on to like Cree Nation lands, territories, and we wanted to know if they know about this, that long-eared owls are up there. Basically an opportunity to share what we've learned so far, see if they already knew this, see if they had any insights to share. And they're not sure so far. You know, we didn't talk to all the relevant people, but the wildlife biologists weren't really sure if they've seen long-eared owls or heard them or not. They know that they see owls, but their focus is more on fished, hunted and trapped species. And, you know, when they see an owl, they appreciate it as an owl, but they're not necessarily identifying it to species. And so they weren't sure if they had any experience with them prior. We think it's most likely they've been using this region for a long time, and it was just undetected that we'd never seen it. It's a great question, though, and we'd love the answer. But
I'm just curious, how much are those 3.3 gram transmitters? And hopefully, if they're expensive, may they please come down in price soon.
yeah, they're not cheap. They're around $1,800 a piece. Yeah. And that's not including the Argos satellite fees for transmitting the data from the GPS to our computers. So it's a small fraction of the price, though.
How do you know if it's a boy or a girl?
How do we know? That's a great question. So we actually don't always know, but there's a slight size difference between males and females. And females are actually a little bit bigger than males in almost all the raptors, hawks and owls. So that's true of saw-whets, it's true of long-eared owls. The females are a bit bigger. In the case of long-eared owls, there's also a bit of a color difference. The females tend to be darker and more richly colored. The males are paler and you know, more subtle colors. But these differences are subtle. So some owls that are sort of intermediate, either in coloration or body size, we just don't know.
There was two or 3 years where the bird flu was really bad. Is there any initiative to try to compare the data of population versus the bird flu to see how much of an impact that had?
That's a cool question. So I'm not well studied in that area. One of our collaborators did just write us a fact sheet for avian flu, specifically with respect to our owl banding operation. It seems like most owl species have gotten it at least once. Individuals, it's been detected in them at least once, but it's pretty rare. And I guess it's because they lead mostly solitary lives. They're not particularly social. And they don't eat, the owls we study aren't eating other birds. So it seems like it's pretty rare in their populations. That doesn't quite address your question, but yeah, I'm not sure if anyone's looking at sort of like large population scale potential impacts of avian flu on owls. I know there's a lot more research on the species that are more affected, you know, game birds and waterfowl. Yeah, yep, exactly. Yeah.
How often do they lay eggs?
Oh, sorry, what was that?
Often do they lay eggs?
Oh, that's another great question. Oh yeah, the question was how often do they lay eggs? So for saw-whet owls, when they're like in a nesting period, so the female goes into her nest cavity or nest box, she'll lay one egg every 2 days or so until she has a full clutch, a full set of eggs. And that usually only happens in like in April, so like early spring. If they're quick about it and there's a lot of food around, she'll actually leave that family and start another one and have another set of eggs all in one season. So that's unusual among owls to have 2 families in 1 year. Good question.
In one of your initial slides, you had mentioned there was a station in a location in Costa Rica that banding was being done. Were the owls migrating from there as well to Quebec or to a different location?
Yeah, so that banding station in Costa Rica was strictly after songbirds, our migratory like warblers and thrushes and orioles and tanagers and such. Interestingly, though, this was not part of our research, but there are short-eared owls that turn up in Costa Rica sometimes in the highlands. When they're undergoing an eruption and short-eared owls are just moving all over the landscape, sometimes they turn up in Central America, which is pretty amazing. And that's probably how short-eared owls wound up in Hawaii. There's a Hawaiian subspecies of short-eared owl. At some point in the past, a couple of birds must have gotten blown over the ocean and wound up in Hawaii.
Quick question about the population here in New Jersey. You mentioned the declining population. You mentioned how it's hard to know exactly the number that's going to overwinter here in a particular year, driven by food. But do we have any idea of a range of a number that's here in New Jersey in the winters of long-eared owls?
Unfortunately, no. I've talked with the state biologists who are, responsible for raptors in particular, and information on long-eared owls is very hard to come by. The decisions about their threatened status were based on some publications, mostly publications that came out of the 1980s that were monitoring roosts in South Jersey and found that roosts were, over the years being abandoned, or the habitat was being converted from suitable roost habitat to non-suitable. There's really no population size estimates, and there's not even great trend estimates. I mean, we've been working with the bird banding lab data, which is probably the best data available, and their populations are so stochastic and variable from year to year that it's really hard to discern a trend from the noise. Some states are finding declines, including New Jersey, but the available data that's based on are pretty poor. So people are being forced to make important decisions with really inadequate data.
Speaking of making important decisions, are there decisions that homeowners could make that could help owls?
Yeah, so it's interesting. I mean, there's some species of owls like eastern screech owls. Somebody asked about, ways to improve backyard habitats and that kind of thing. Putting cavities on your property might attract screech owls. It's a very difficult thing because their home ranges are quite large. So some of the slides I skipped over, we used a different type of GPS to track local movements to try to get a sense of their space requirements. And some owls have home ranges as small as 80 acres or so, but the typical long-eared owl had a home range more like 800 acres or maybe even a bit bigger. So for most of us, we could only be managing at most a tiny fraction of a long-eared owl winter home range. So I think besides targeting your local resident species and trying to give things like cavities or trying to install conifers, plant appropriate trees for roosts for things like saw-whet owls, then I think the next best thing is just, promoting conservation orgs, encouraging land acquisition, trying to encourage stewardship for winter bird species. So something that I feel like needs a little bit more lobbying from people like you is a lot of management focus in our parklands, nonprofits, they really focus on the breeding population of birds. And that is very important. I don't want to undermine that in any way. But winter is a time of higher mortality for a lot of our threatened birds, including early successional species like long-eared owls. And I think in some ways, because the habitat's not supporting breeding, it's seen as less important. But that, in my opinion, that's not the case. The overwintering habitat could be just as, if not more important than breeding habitat. One of the things that we found with long-eared owl selection is we saw some evidence. It's circumstantial, and I don't want to get too deep into it, but basically they're selecting their home ranges, like where they're setting up shop for the winter, based on availability of suitable roost habitat. not availability of suitable foraging habitat. And so that gives us a sense that it's something they need more of in the landscape. And at least in our region, these are habitats that are mostly becoming aged, converting into, you know, more mature forests, or being converted to developments and, you know, just habitat loss in general. So yeah, so I think encouraging more stewardship of public lands and nonprofit lands in ways that incorporate our non-breeding bird populations would be a really good thing. Because managers do listen, you know, they want to know people's priorities. Usually they focus on the breeding birds, but our non-breeding birds need help too.
You mentioned that the radio transmitters are about $1,800. In contrast, how much does a leg band cost?
So just a quick clarification, it's the GPS tags that cost, you know, depending on the type of tag, $1,200 to $1,800, and the ones we use, $1,800. Radio transmitters like the kind we use to track saw-whet owls back to roosts, those are like 10 times cheaper. They're, you know, like $180 or so. The leg bands themselves, they're actually free to licensed bird banders. The bird banding lab distributes them for free, but they're, you know, pennies. Yeah, each band is probably less than yeah, I'd say less than a nickel for sure.
I just had another comment on what homeowners could do to help.
Please, yeah.
I spent 28 years volunteering at a wildlife center aside from my regular job. Do not put out rodent poison, because they will go outside and die or be eaten by something. We used to get a lot of birds that were poisoned, and also pesticides. Screech owls, and they eat a lot of insects. And at the time we had an education bird that was born with his beak crossed, so it could never survive in the wild. And that was genetic defects from pesticides. So yeah, also have to be aware of what your actions are doing on a bigger picture.
Yeah, thank you for that comment. I didn't think about that angle, but that probably is one of the most important things you can do to protect owls, particularly the rodenticides, you know, rat poison. And yeah, it's terrible for birds of prey.
Is there any contamination with microplastics that affect bird populations? Supposedly in humans, microplastics are possibly responsible for a decrease in sperm count in you know, males. And so is that you know, a possibility in any of the habitats that is affecting the population?
It's a great question, and I don't know. Does anybody have an answer? I'm not sure. That's not something I've ever looked into. I will.
The photos you showed were you trapped at night. Do they only migrate at night?
Yeah, yes. So they do only migrate at night. And yeah, based on the capture rates, we can say that more owls are moving early in the night than later in the night, which is interesting. So shortly after sunset seems to be the biggest push, and then birds will move throughout the night though. But yeah, it's interesting. And as far as nightly migration distances go, I know you didn't ask, but I'm going to tell you anyway. As far as nightly distances go, hugely variable. Mostly it was short distances, but I'm speaking of long-eared owls now because we have good GPS data on it. Mostly really short distances, like less than a mile sometimes, but then it would be punctuated by moves of, you know, 150 or 200 or sometimes 300 miles in one night. Really interesting. We don't know what motivates them to make those giant movements, but yeah.
I think we have time for just one more.
Reporting owls, I'm talking about citizen science, reporting owls on such platforms as eBird can result in a lot of problems. But I'm sure there's a lot of data out there that either, how could we make sure there is data available, and do you use any of that other type of data?
Yeah,
it's from Cornell.
I feel like that's a really conscientious question. So I'm not a big eBird user, used to be more so. My understanding is you can obscure observations on eBird to protect owls, yeah, but still be able to report the data so that it's safe, it's somewhere centralized. I haven't used eBird data before, but colleagues of ours, including the person who is working on this migration map showing the eruptions, spatial and temporal variation in eruptions. He works a lot with big data, and some of his research involves eBird too. It is really useful, and so I know that reporting owls to eBird is fraught because if it's not done responsibly, it can make the owls really vulnerable to harassment. It's so useful though that once it's in there, so it's a tough double-edged sword. I think obscuring the observations is really crucial. Yeah, a quick minute about that, just because we're coming owling season. I'd like to think that there are sort of sustainable and ethical ways to search for owls. It gets really problematic when the natural impulse to share the experience overtakes us, and we tell people where we have found owls. I feel like it's one of these things that minimal disturbance, 1 or 2 people, it might be okay, but as soon as word gets out, it's not 1 or 2 people. The owls are so attractive to birders and photographers, and I completely understand the appeal. I do. I mean, you just sat through me talking about how much I love owls I get the appeal, but definitely be very careful with those locations. It protects the owls from harassment. It's at a time of year where they're really vulnerable to burning energy. They don't have excess energy to waste, so flushing them from roosts repeatedly can really affect them. Yeah, I think I would not discourage people from going out to look for owls. In fact, I think it can be done safely and responsibly, and it's a great way to just keep your love of these birds alive. And but guard that information.
Thank you, Tyler. Could we all please give Tyler another round of applause? That was really fascinating, and I'm sorry we had to skip a couple of slides because I was really intrigued by those. So I hope you come back and speak again for us.
Sure.
I'd like to thank Tyler, thank the Watershed Institute. Thank you all for coming. Thanks for everyone who joined us online. Please keep an eye out for that email that's coming your way, because Tyler's going to give me some great reference materials that you can learn more about owls. And again, remember to please fill out that survey. And if you're not already a member, please join us and help support the work that we're doing to restore the forest so that we can give those owls some healthy habitat to migrate or breed in. Thank you. Thank you.
Thanks for everything you do.